a three-dimensional figure. Okay. All right. So we live in a three-dimensional world and thus deal with solids or three-dimensional shapes all of the time. There are literally an infinite number of these shapes. In today's lesson, we're simply going to introduce the most common ones that we're going to be using to help model geometric problems. So a prism is a solid. I'm looking for a Kleenex box. A prism is a solid. Has two congruent faces. This is a face. This is a face. It has two congruent bases. This is a base and this is a base. It has two congruent sides. This is a prism. Okay? This is a prism. This is not a prism. Okay? The bases are all parallelograms, or the faces are all parallelograms, and this is not a parallelogram, any way, shape, or form, right? So a lot of times we think that cylinders are prisms, but they're not. So we're talking about prisms. A prism is made up of any type of polygon base. Polygon base. So you can have a pentagonal prism, a hexagonal prism, and then all of the faces are parallelograms. So this is a square prism or a cube, maybe, we think it's a cube. This is a pentagonal prism. All of the faces are rectangles, which are parallelograms, okay? So a prism is a solid that has two congruent faces with all of the other faces being parallelograms. The two examples of right prisms are shown. Why do you think that those are called right prisms? Because the faces are perpendicular to the bases. Let's say that. So the faces are perpendicular to the bases. So that means that if this, I'm going to kind of shade this in. If this is the base, this face is perpendicular to that. This face is perpendicular to that. If this is my base over here, this pentagonal prism has a pentagon base. They all make right angles, okay? They're all perpendicular. I don't know if you can really see that or not. I'm going to blow it up nice and big. Do you guys see the right angles that I drew in there? Okay. If you sliced a prism, I always think of this as a block of cheese. 2 years ago, I brought in a bunch of blocks of cheese. I don't think I can afford to do that this year, but we'll see. Maybe I'll have my dad cut us a bunch of wood. So if you were to slice a prism with a horizontal plane, what would be true about the cross section? So if I were to cut this in half or just slice a horizontal plane through it, what could you say about this cross section? Compare the cross section to either one of the faces or one of the bases. The cross section is what? Guys, can you see that? What can you say about that cross section compared to maybe, I don't know, the base? They're the same. Yeah, they're exactly the same. So the cross section would be or is congruent to the base. The cross section is congruent to the base. Are we good with that one? Okay. If you sliced a prism with a vertical plane, so here's a prism. This is a triangular prism. Here is the top or the top base. Here is the bottom. And all of the faces are parallelograms. If I were to slice this with a vertical cut, if I were to slice a vertical cut through here, what do you see? What can you say about the cross section? Is it a triangle? No. What is it? Yeah, we're going to call it a parallelogram because we really don't know anything specific about the faces except that they're all parallelograms. Is that okay? So it would be a parallelogram. This cross section would be a parallelogram. Depending on how far away you cut it, right? Like if this is one of the faces, what could you say about these two? This is a little bit out of the box thinking, but what could you say about these two dimensions? They're not congruent to each other, but they're what? Who said that? Zach. +1. Yeah, they're proportional. Good job. Okay. All right. A cylinder is a shape very similar to a prism, except the base face is enclosed by a curve rather than a polygon. Typically, the curve is a circle. The most common is a right circular cylinder. Why do you think we call this a right circular cylinder? Any ideas? Okay, well, if you think about, I'm going to leave this picture here and I'm going to draw another cylinder. What can you tell me about that cylinder? It's crooked. It's called oblique. It's called oblique. So same idea. The sides are perpendicular to the base. Like if I were to draw a radius in here, you could see that the sides are perpendicular to the base. These pictures are so dark that I don't feel like my drawing's showing up, okay? So for a right circular cylinder, the most common one is shown. What are the two measurements that control the size? Well, I just drew one of them. The radius. And even if it's oblique like this, it's still a radius measurement. What else do you think controls the size? The height. So the radius and the height. What two-dimensional shape wraps itself around the surface laterally? So this is such a great question. I'm so glad I have this roll of paper towels. Can't imagine my assistants. We're going to pretend that this is just the lateral face. I want you to draw a line right here. Perfect. So what shape laterally wraps itself around here? Well, if I unwrap it, what is this? A rectangle. Okay, so let's write that. A rectangle. Remember that a rectangle has dimensions length times width, right? So I'm going to kind of think about unwrapping this so you guys can see this unwrapped piece of like paper. So this is my unwrapped piece of paper. My length actually is the circumference, and my width of my rectangle actually is the height of the cylinder. I just want to kind of put into perspective what that length and that width represent. So if I were to take a two-dimensional figure, two-dimensional figures are flat figures. If I were to take a two-dimensional figure and rotate it, so I'm going to put a little rotating stick here. This is my little rotator. If I wanted to produce a right circular cylinder, what kind of shape could I attach to my stick and rotate around to make a cylinder? So what shape? Yeah, a rectangle or a square, right? You guys see that? I mean, like if this were the rotator and this is the shape, what does this make when you spin it? It makes a cylinder, okay? So we want to attach some type of rectangle. So I'm going to draw just a rectangle coming off of it. And then as I rotate it, whatever the radius measure is the length of my rectangle, and the width becomes the height of my cylinder. Is this okay? Are you guys understanding this? Is this simple, basic, hard, don't make sense? All right. So let's talk about a pyramid. A pyramid is a type of solid where one face is known as a base, and it's a polygon base. And the faces are all triangles that meet at a common vertex. So I know these pictures are so dark, and I don't know why that is. So if you think about, this is my base, right? So I have some kind of rectangular or quadrilateral shaped base. This is one face. It's a triangle. This is another face in the back. It's a triangle. I have this face off to the right. It's a triangle. And then I have this face on the front. It's a triangle. Just trying to get you to see that however many sides your base has is how many triangular faces you have. Okay? So it says, explain why the horizontal cross section of these pyramids would not be congruent to the shape of the base. Because remember when we had a rectangular prism and we cut that horizontal cross section, it was congruent to the base. But now I have this base down here, and when I cut my horizontal cross section up here, they're not congruent to each other. Why? Yeah, the horizontal cross section is smaller. They are similar to each other, which means that they're proportional. Similar, it means that they have the same proportional measurements, they're just not congruent. Their measurements are proportional, and that proportion extends throughout the whole shape. Under what condition would the triangular sides of the pyramid all have to be congruent to each other? The base would have to be the base is a square. If the base were a rectangle, the faces wouldn't be, yeah, this one would have a bigger triangular base than this one. Does that make sense? But there's a special kind of polygon that you guys learned of in probably 8th grade, definitely math 2. So yes, a square would work. What if my base was a I'm going to try to draw this as neatly as I possibly can, which is not very good. But what if I did this? Or if I drew a hexagon and I did this as well? What does this mean when I mark all the sides like that? That they're all congruent. So it's not necessarily that the base is the square, but the base needs to be we call that a regular polygon. A regular polygon. What does that mean? That means all sides are congruent. Okay. The other thing that would have to happen is I'm going to kind of slide off to the side and I'm going to just draw a sketch. So if this was my pyramid and I drew it like this, I want you to look at that one compared to, I'm going to try to just copy that same shape, only I'm going to do something different. What did I do here? This top piece of your pyramid where all the vertices meet, this is called the apex. The apex is directly in the center of the regular polygon in that top image. But when I look at my bottom image, the apex is not centered. It's slanted, kind of like that idea of being oblique. So they'd have to be regular polygons, meaning all sides are congruent, and the apex, and I'm just going to put in parentheses, top vertex must be centered over the base. Okay, because if it's not centered over the base, look at that other picture, then those pieces aren't going to be congruent. I know I'm not an artist, but do you guys understand by the two pictures I drew? Does it make sense? Yes, no, maybe? Okay. All right. Raise your hand if you need more time with that one. Okay. Okay. So a cone is a shape that's very similar to a pyramid, except that the base is enclosed by a curve, meaning we have a circular base, right? Instead of a polygon with straight sides. And like the cylinder, this curve is most often a circle. The most common cone is a right circular cone. And again, we call it right because when I think about the apex, right, this makes a perpendicular with the base. It's perpendicular to the base. So similar to a cylinder, a cone can be produced by rotating a common two-dimensional shape. So if I think of this as my little x-axis, what shape would I need to rotate around this to make a triangle? Yeah, any kind of triangle, right? If I spin this around, what's going to happen to it? Well, this is going to go like this. And this top piece is not going to really move at all. So it's going to end up making a shape like this. Okay. So we said any kind of triangle. And we look at it. What do we know about the base and the height? What are they to each other? What makes it a right? Yeah, so we call that actually a right triangle. Yes, good job. Gotta be a right triangle. So we're going to describe the cross sections of the cone from below. So this is a horizontal cross section. This is a horizontal. What can you say about this? Okay, so that means it's going to be the same shape as the base. So I'm going to write circle or same shape as the base. But is it the same size? It's just smaller, right? Do you guys see that? You see that it's going to be smaller than the base? Okay. What about this? This is a slanted cross section. Slanted. Sometimes we call that an oval or an ellipse. Depending on how you, if I were to maybe start my knife right here and cut it this way, it'd be very elongated, right? So it's just an oval or an ellipse. You could even call it maybe an elongated circle. I don't know how you think about that. Elongated circle. Okay. Ellipse is the correct math term. This is taking a cylinder, just cutting a chunk off of it. Taking a chunk off the side. Looks a lot like a parabola, right? So I'm going to call it a parabola-like shape. And then if I were to cut through the apex with my knife, so like, I'm going to try and draw a knife. Here's my fabulously sharp knife, right? And I'm cutting right through the apex. And I cut right through the center in such a way that I split the bottom exactly in half. What shape does this make? What shape does this make? Yeah, it makes a triangle. So your homework today is just on cross sections. Just on cross sections. Okay. Pages 7 and 8. Pages 7 and 8. Very, very, very easy. Super chill kind of